Hello students, this week we'll be using graphs to represent ratio relationships. Remember, when you say ratio, that's a comparison of two quantities. And when we graph, we need to have our ordered pairs. So let's start. Let's look at the problem. It says an airplane travels 300 miles per hour. So our ratio would be 300 miles per hour. Now, what do we do with this information? And you're absolutely right. We need to generate equivalent ratios. But how do we do that? From our last topic, we use ratio tables. So we can use a ratio table right now. So let me do that. And let's draw a ratio table. Let's see, this will be my table. Ooh, it's not that straight. Now, when you do your ratio table, make sure that you label your table. When you say label, what does the first row represent? What does the second row represent? Now, when you go to your textbook, it says there that on the first row, this represents your x-axis. And on the second row, this represents your y-axis. So your x-coordinates and your y-coordinates. Now, looking at the graph, we can see that on the y-axis is represented by distance, and on the x-axis is represented by the time. So let's label your graph, okay? So this is your y-axis, and this is your x-axis. So we already know that the x-axis is represented by time in hours. Ooh, let's undo that part. So in hours. Need to have a better handwriting. Now for my y-axis is distance in miles. Here we go. Distance, and write it here in miles. So don't forget, usually the first row is your x, represents the coordinates for the x-axis and the coordinates for the y-axis. So the ratio would be 300 miles per hour. So that means for every in 1 hour, the airplane travels 300 miles. If you add another hour, the airplane traveled another 300 miles, so that's going to be 600 miles. So if the airplane traveled another hour, so that becomes 3 hours, now the distance it travels will be 900. You add another 300. Now remember that these things right here, these quantities, okay, these quantities are equivalent ratios. These are your equivalent ratios. Now, why are these important? Remember what I said earlier? We need our ordered pairs. Now, when you say ordered pairs, that is your x and y coordinates. So let's write our ordered pairs right now. So I'm going to use red. When an x is 1, right here, 1, y is 300. When x is 2, and remember, x represent time. For in 2 hours, the plane travel. Oops, I don't need that. Here we go. The airplane travels for 600 miles. Now, for 3 hours, the airplane travels 900 miles. So these will be our ordered pairs. Now, let's graph this, okay? Now, on this graph, as you can see, let me do this. There you go. Okay. So on this graph, you can see we have a move, we have a point, we have a ray. This is our x-axis. This intersection right here is your origin. That's the 0, okay? Now, remember, our ordered pairs is x and y. X is the horizontal, let me close this one. X is the horizontal line right here. So when x is 1, look for 1. 1's right here. And it says y is 300. So we go up 300, and that is our point. Oops, let me use point. And that is our point right there. So x is 1, y is 300. Now, second one, 2 and 600. When x is 2, y is, the distance is 600 miles. So I'm going to go up to 600. And I'm going to put my point right there. That's 600. Now, when x is 3, on 3 hours, it travels 900 miles. So I'm going to go from my horizontal line, the x-axis, 3, and go up to 900. Now, we need to connect these points, okay? So this is our A. Now I'm going to draw a line right here. Here we go. That's our line. Now remember, if I were to extend this line, if I were to add another hour, that means I need to add another 300 from 900, and that becomes 1,200. So if the time is 4 hours traveled, we go up, and that's going to be 1,200 miles. So this is what we connect the line as well. So this would be your graph. Now, what do this mean, this graph right here? So I'm going to write out these points. Now, these points represent something, okay? So this point is your, let me write it down, there you go. This is your 1 and 300. This point is your coordinate, your ordered pair 2 and 600, and this would be your 3 and 900. Now, why are these important? Let me change color. So you need to remember that this is your x, this is your y. The x represent the hours. So in 1 hour, the airplane traveled 300 miles. And this is your x, and this is your y. I forgot to close parentheses. So in 2 hours, right here, the airplane traveled 600 miles. In 3 hours, the airplane traveled 900 miles. So see how important labeling your graph and also labeling your table to generate equivalent ratios. So this is how we graph. Hopefully this helps. Now let's move on to a second exploration problem. Okay? Okay, so for our second exploration problem, it says identify relationships in the graphs. Now previously, we were given a ratio problem and we were graphing the situation, the scenario. Now we are given a graphs and we need to look for the equivalent ratios. So it says use the graphs, or these two graphs, to make a ratio table. Now, what do we remember about graphs? Now, this is your y-axis and this is your x-axis. So let's label that for a minute. Do that. So this is your y-axis and this is your x-axis. Now, remember what I said about the graphs and the points, right? So these points right here represents an ordered pair. So let's write the ordered pair for the first one. It says, so ordered pair is x and y, right? Let's change color. Let me use this dark green right here. Okay, so this point, so x and y. Now our x and y, let me write all x and y right here. It's flickering. Let me turn off the focus. There you go. That's better. And I'm going to change it to orange. All right. So this point right here represents our x is 5, y is 2. Now this represents, what is x? It falls on 10, and y falls on 4. Now this last point, the x falls on 15, and the y falls on 6. Okay, now let me highlight that for you. Now these points represents quantities, okay? So when x is 5, that means for 5 fluid ounces of milk for your x-axis, you will have 2 ounces of cereal. And for the second point, the x is 10, that means for 10 ounces of milk, you'll have 4 ounces of cereal. And the last point is for 15 ounces of milk, or fluid ounces of milk, you'll have 6 ounces of cereal. So all these points on this line represents what? Absolutely. It represents equivalent values, equivalent ratios. It forms a straight line. And it starts at 0, 0. That means if you have 0 milk fluid ounces, you have 0 ounces of cereal, right? So that's how we interpret graph or read graphs. So these points have values, it has meaning. So let's complete the table. Now it says milk fluid ounces. What values do we start? Let's start with 0, 0. Because if you have 0 fluid ounces, that's 0, oops. If you have 0 fluid ounces, that means you get 0 ounces of cereal. Now, the next one would be x is 5. X is 5 for 5 fluid ounces, y is 2. Next is 10, and then 4. Next is 15, and then 6. Now, do you notice it says 5, 10, 15, yet 2, 4, 6? We're adding the same ratio. If you add 5 more fluid ounces, it becomes 10. That means you need to add 2 ounces of cereal. Now, if you want to multiply, yes, you can, but you need to multiply with the same factor number. So 5 times 2 is 10. So 2 times 4 is, 2 times 2 is 4. Now 5 times 3 is 15. That means 2 times 3 is 6. So what do these blue and red arrows correspond to the ratio table? So the red and blue arrows correspond to equivalent ratios. Exactly. You see how consistent we are? We add 5, then and we go up 2. Then we run 5, then we go up 2, then we run another 5, then we go up 2. It's the same thing as on our table. We're adding 5 and we're adding 2 at the bottom as well. So that's a constant when we graph ratio relationships. Okay? So let's move on to the next graph. On the next graph, it says the green arrows, it says times 3 and times 3. What does that mean? So you're looking at the times 3 here. This is going up 2. Oh, let me use a pen. This is going up 2. So from 2, it becomes a 6. So 2 times 3 gives you 6. That means, because this is our y-axis, the 2. Now for the 5 for our milk, if you multiply 5 by 3, you get 15. So 9 times 3 is 15. Just like our table up here. Second. Oh, where's the arrow? Yeah, here we go. Oh, it doesn't work. Okay, never mind. So just like our arrows right up here, 5 times 3 is 15 and 2 times 3 is 6. So these green arrows, it represents a factor, right? A factor to increase our ratios or to also generate equivalent ratios. So this is a common factor to generate equivalent ratios. See how easy it is? Now let's do more examples. Okay, so let's try another example. It says represent the ratio relationship using the graph. Now remember, this first row right here would be our x values, and this would be our y values. So let me write that out. Again, our first column, always, this represents our, oops, let me use a pen. This represents our x, and this represents our y-axis values. All right, so let's write down our ordered pairs. So our ordered pairs would be for every 1 minute is either you type 50 words. So 1 minute, 50 words. For 2 minutes, 100 words. And for 3 minutes is 150 words. Now, let me change this color. Blue. Remember, this is your X. When you do your ordered pairs, this is your Y. The first column usually is your x-axis. Now, if it's a row, then just like our exploration 1, that will be your x, and the second row will be your y. But in this case, we're in columns, so first column your x, and the second column will be your y. So let's check the graph. All right, let's scroll this down. Now, when you do the graph, as you can see, it should be fairly easy. Let me erase this part right here. So you have this line, and the graph is already there. So all you need to do is just plot the points. Should be fairly easy for you. Your homework should be similar, okay? Now, your x-axis is the time, and your y-axis would be your number of words. So it says here when x is 1, so that's the time in 1 minute, you have 50 number of words, or you type 50 words. So 1 minute, you go up 50. Now this is 50 right here. It's labeled for you, so you don't make your own graphs now, or number your own increments. It's done for you. Now, when in 2 minutes you go up 100. There you go, and the line just automatically connects. Even I'm not done with the 3 yet. So 3 minutes you go up to 150. Now let's write on these values. I'm going to choose red. Now, what do these points mean? So it means that, so for 1 minute, you type 50 words. For 2 minutes, you type, for 2 minutes, you type 100 words. And for 3 minutes, you type 150 words, because this is your x, this is your y, this is your x, this is your y. So you can actually use graphs to answer ratio problems. Now remember, if you're graphing ratio relationships, it always starts at 0. Okay, so let's try this problem. Now we have our number of 6th graders and number of 7th graders. Remember what I said, the first column will represent your x values, and then this will be your y values. So let's get our ordered pairs, okay? So our ordered pairs, I need to really improve my handwriting. There we go. My ordered pairs, my x and my y, would be for every 5 6th graders, we have 4 7th graders. For every 10 6th graders, we got 8 7th graders, and we got for every 15 6th graders, we have 12 7th graders. Now, we have our ordered pairs. Now let's graph. When we graph, the labels are already done for you, so it should be easy. Now, this is similar to your homework, so hopefully it will be easier for you. Now, let's graph this out. Oops, that's why it's not moving. All right, so the number of 6th graders, this will be your x-axis, so this is your x, and the y would be the number of 7th graders. So for every 5 6th graders, there's 4 7th graders labeled for you. Now for every 10 6th graders, there's 8 7th graders. I'm not even done yet, but it formed a line right away. Great job, big ideas. Now we got 15 6th graders, and we move up to 12 7th graders. Now remember what these values mean. So let me write this out. Let me change the color. And let me do orange. So this is your x value, which is 5 6th graders, and your y would be 4 7th graders. So this represents the 6th grade right here, and this represents the 7th grade. And this point value means for every 10 6th graders, there are 8 7th grade. This is your x, this is your y. And your last point right here, this right here, is 15 6th graders, then there will be 12 7th grade. So this line represents your equivalent ratios, and it shows the relationship. And so you always start at 0, because when you're graphing ratio relationships, it always hits the origin. Hopefully this helps. Make sure that you do your homework. Thank you. Bye.